friends, welcome to all of you in our physics lecture. Our today's physics lecture is based on circuit theory, which is the topic of chapter alternating current taken from class 12th. We have to study in this topic uh, pure resistive circuit, pure inductive circuit, pure capacitive circuit, LR circuit, CR circuit. So let's start to study them one by one. Pure resistive circuit. Suppose we have a wire whose resistance is R and it is connected with AC source and this AC source having potential which is defined as B is equal to B naught sine omega t. Because this is resistance and some potential will drop across here. Suppose this potential drop is VR. Now we apply Kirchhoff's voltage law in clockwise direction. So apply Kirchhoff's voltage law. The input voltage is V and voltage drop across the resistance is VR. Now the KVL is applied like that, V minus VR is equal to 0 because KVL is summation delta V is 0. Delta V stands for potential difference. Now VR will be written as VR is equal to V and the value of V is defined as V naught sine omega t. And as you know that the voltage drop across the resistor is defined as when the current is I flow through this circuit, then it is defined as IR according to Ohm's law. V naught sine omega t. Then we can find the value of I from here as V naught over R sine omega t. And as you know that this is the form of current V naught over R according to Ohm's law. Then we have to write it as I naught sine omega t. We have a voltage equation which is input V naught sine omega t and the current equation I naught sine omega t. So value of I naught just less than the value of V naught because V naught is divided by some resistance, then I naught will decreases in the comparison of V naught. And we also know that very well what is phase. Phase is the angle which contained by sine or cos function. This is called phase. Now if we take the phase of current is like phi 1, then phase of current is omega t and the phase of voltage is also omega t. Now the formula of phase difference which is denoted by the symbol delta phi, is mod of phase of V minus phase of I. Phase of V is omega t minus phase of I is also omega t. Then the phase difference becomes 0. It means current and voltage are in same phase. Because the phase difference between voltage and current is same, means phase difference is 0, hence voltage and current becomes in same phase. Now we analyze this by using phasor diagram. Phasor diagram. Suppose this shows the voltage B, then current is also along it, which is I, and both have phase difference 0 and having same phase omega t and omega t. Now this axis shows instantaneous values of voltage or current. What? Instantaneous value. This y-axis shows the instantaneous values of voltage and current, and this axis shows time axis. And suppose this is the peak value of voltage, this is peak value, and we know very well the value of I naught will less than the value of B naught. Hence, because voltage and current both are in same phase, then the peak value of current is also along this, which is some less than the value of B naught. And the projection of B naught along this axis will be B naught at the angle of omega t from the x-axis. B naught sin omega t, and the projection of I naught means peak value of current is I naught sin omega t. This is the instantaneous value of voltage and this is the instantaneous value of current. This is the phasor diagram, and this shows voltage and current both are same phase. Now analyze this by using wave diagram. Wave diagram. This is the time axis, and here we shows instantaneous voltage or current. Because as we know that the voltage equation is V is equal to B naught sin omega t, where B naught shows the peak value of voltage, and the instantaneous current equation is defined as I naught sin omega t for pure resistive circuit. Both having the same phase difference, but value of I naught is less than B naught. Then this graph will be sinusoidal, and it is like that. we draw for a one cycle, and this shows V is equal to V naught sin omega t. Then the graph for instantaneous current will be drawn as having same phase difference, but the value of I naught is less than V naught. So this graph is for instantaneous current I naught sin omega t. We always remember in pure resistive circuit, the voltage and current both are always in same phase. Now we study the next circuit, which is pure inductive circuit. Second circuit is pure inductive circuit. We draw the diagram for pure inductive circuit like that. As we know that the inductor shows like this. This is the symbol of inductor, and it has self-inductance L. We connected this with an AC source having input voltage V naught sin omega t, and we assume the current I at an instant of time flows through this complete circuit, and some potential generated here, which is symbolically represented as VL. Now we have to find here the instantaneous current equation, which is flow through the circuit. Now apply in the circuit KVL. Apply KVL means Kirchhoff's voltage rule, which is summation delta V is equal to 0. Here we have to apply the voltage V minus, here we apply the voltage which is inductive voltage VL is equal to 0. Then VL written as V means VL is equal to V is V naught sin omega t, and the EMF means voltage generated across this inductor is L di over dt. Suppose the current I flow through this circuit is equal to V naught sin omega t. Now di is V naught over L sin omega t into dt. Now taking integration on both sides, integration of Ti equal to V naught over L are constant, integration of sin omega t into dt. The integration of di is I is equal to V naught over L, and the integration of sine function will be minus cos, and the angle is omega t, then angle is omega t divided by omega. Because we integrate it with time, then the coefficient of time will be divided. Now, the equation of I is defined as B naught over omega L minus here cos omega t. As we know that this is the peak value of voltage and this is omega L. And this omega L can be represented as B naught over XL. And we convert the cos function into sine function, then we know that it can be converted like that, sine pi by 2 minus omega t, means sine 90 minus omega t. Now we have to multiply this negative sign inside the sinusoidal function B naught over XL sine. It becomes now omega t minus pi by 2 after multiplying with negative sign. And you know that this is the something voltage over resistance, means this shows the peak value of current. I is equal to I naught sine omega t minus pi by 2, where I naught is B naught over XL and XL is looking like a resistance which is phasor quantity and treated as vector. That's why we make and draw here phasor diagram. This is like a resistance having unit O like resistance because it is a resistance. But this resistance XL is called as inductive reactance. The symbol XL is working as a resistance in inductive circuit, which having the same unit as a resistor, which is also known as inductive reactance. Now we have find the equation of instantaneous current I is equal to I naught sine omega t minus pi by 2. It means that the phase difference delta phi is the phase of V is sine omega t. Phase of V is omega t minus phase of I is omega t minus plus pi by 2. Now the phase difference becomes pi by 2. The phase of voltage is omega t and the phase of current is omega t minus pi by 2. It means that the current lags behind the voltage because the phase of current is negative, means current lags behind the voltage. In pure inductive circuit, current always lags behind the voltage by pi by 2. Now we can draw easily phasor diagram on the basis of this information. Suppose this axis shows the instantaneous value of voltage and this axis shows the value of instantaneous current. The phase difference between them is pi by 2 and current lags voltage by pi by 2. This current behind the voltage by pi by 2. We can draw this diagram like as this is the time equation, and this shows instantaneous value of voltage or current. Then as we know that the phase difference of voltage is omega t, then this arrow will show the peak value of voltage at the angle of omega t. Then the projection of this voltage along this axis will be V naught sine omega t. And as you know that from this current equation, current lags behind voltage by pi by 2. Then the phase difference between voltage and current will be 90 degree, means pi by 2. Then the instantaneous value of current is I naught sine pi by 2 minus omega t, because the angle is pi by 2 minus omega t. This shows the instantaneous value of current, and this shows the instantaneous value of voltage. Now we make wave diagram. Wave diagram. This axis shows the instantaneous value of voltage or current. As we know that the equation, the instantaneous voltage equation is V is equal to V naught sine omega t, and the instantaneous value of current is I is equal to I naught sine pi by 2 sine omega t minus pi by 2. Hence, as you know that the value of I naught will be less than the value of V naught. Then the graph of voltage will be sinusoidal like that for one complete cycle. Then this shows instantaneous value of voltage V naught sine omega t, and the instantaneous value of the equation of current is I naught sine omega t minus pi by 2, means current lags behind voltage by 90 degree, means whenever the voltage is minimum, then current will be maximum in negative direction. When the voltage becomes maximum, then current becomes minimum, and so on. Then the graph of current is like that. This graph is for instantaneous current. I is equal to I naught sine omega t minus pi by 2. This is the wave diagram, and this is the phasor diagram for pure inductive circuit. Now we move our next topic, which is pure capacitive circuit. Our next topic is pure capacitive circuit. It can be represented diagrammatically as the symbol of capacitor is this, whose capacitance is C, which is connected with an AC source and the instantaneous voltage is defined as V naught sine omega t. And we assume when we apply the AC voltage source, then some charge start to flow from there, and the instantaneous charge is Q, which is flowed through this capacitor, and some voltage drop across here, which is represented as BC. Now we apply here in clockwise direction KVL. So apply KVL. KVL stands for Kirchhoff's voltage law, which is summation delta V is 0. Now we apply KVL here. V minus Vc is equal to 0, and the value of Vc means voltage across capacitor, defined as Q by C. Instantaneous charge is Q. Suppose we have charge on capacitor is Q and has capacitance C. Then the value of voltage across the capacitor is Q by C. Now Vc is defined as V, and the value of Vc is Q by C, and the value of V is V naught sine omega t. Then we have to find here the value of Q, which is the instantaneous charge, as CV naught sine omega t. Then we can write the equation of charge as by differentiating with respect to time. We have to differentiate this equation with respect to time. Then we get dq over dt. CV naught will become constant, and we differentiate this sine omega t function and convert it into cos omega t. Because we differentiate it with respect to time, then we assume the omega t as a time. Then we further differentiate the term omega t. Now we get omega, and the value of t becomes 1. Now, as we know that this is the rate of change of rate of flow of charge, and the rate of flow of charge defined as instantaneous current. This is omega c v naught cos omega t, and we can write this equation as I is equal to, this is v naught over 1 over omega c, and this behaves like a resistance for capacitor, and we convert this cosine function into sine function as sine omega t plus pi by 2, because as we know that very well, sine 90 plus theta is always cos theta. Then we convert it sine 90 plus omega t treated as theta. Now we feel here 1 over omega c is like a resistance having the same unit ohm, and we have to represent this term as Xc, 1 over omega c, which is also known as capacitive reactance. This is called capacitive reactance. Now we have to find the phase difference between voltage and current. Phase difference delta phi will be, the phase of voltage is omega t minus the phase of current is omega t minus pi by 2. Then omega 2 negative will cancel out, we get pi by 2. Hence, as we seen from the specification of current and voltage, current leads by pi by 2. So we can say that here voltage lags behind current by pi by 2. Now we can understand it by using phasor diagram. Suppose this shows instantaneous current, then this axis will show instantaneous value of voltage, and the phase difference between them will become 90 degrees. Suppose this axis shows instantaneous value of voltage or current, and this equation shows time. Then the arrow shows peak value of voltage, and it is at the angle of omega t, or may be called as phase of voltage is omega t. Then current leads by pi by 2 of voltage. Then the arrow of current will be here, shows the peak value of current, which is lead by angle pi by 2. This is the phasor diagram of voltage versus time, or instantaneous current versus time. Now we can study better by using wave diagram also. Wave diagram. This axis shows instantaneous value of voltage or current. Then, as we know that the instantaneous voltage equation is V naught sin omega t, and the instantaneous current equation is I naught sin omega t plus pi by 2. Hence, the graph for voltage will become sinusoidal, and it is like that. This graph shows one complete cycle, and we have to draw for instantaneous current. Then current leads by pi by 2, means whenever voltage is minimum, then current becomes maximum. Hence, the graph of current will start from here, because at t is equal to 0, sin it will produce sin 90, and sin 90 always maximum. And when the voltage maximum, then current will become minimum. When voltage minimum, then current becomes maximum. So graph becomes like that. This graph shows instantaneous value of voltage V naught sin omega t, and this graph shows instantaneous value of current I naught sin omega t plus pi by 2. I think students, you understand very well. So thank you so much.